Welcome back, Chef, to another exciting episode of the Culinary Study Guide. Today we're diving deep into the fascinating world of food science and exploring the effects of heat on food. In this episode, we'll look closer at how heat transforms proteins, carbs, and fats, uncovering the secrets behind those mouth-watering textures, flavors, and aromas we all love. Whether you're a seasoned chef or just starting your culinary adventure, understanding the science behind heat and its impact on food is crucial to mastering the art of cooking. If you'd like a SparkNotes version to follow along, we've prepared detailed notes and textbook references for you in the video description below. So if you want to delve deeper into the culinary science, check them out. Lastly, if you enjoy this video and want to stay updated with our latest culinary explorations, don't forget to hit the subscribe button and ring the notification bell. You'll become a part of our vibrant community of food lovers and aspiring chefs by subscribing. If you find this video helpful and informative, a thumbs up would mean the world to us. Your likes and feedback encourage us to create more content like this, sharing our passion for cooking and unraveling the kitchen's secrets. Thanks! Okay, let's dive in. There's something to be said with cookbooks. No written recipe can be 100% accurate, no matter how carefully a recipe is written. The judgment of the cook is still the most critical factor in a preparation turning out well. A cook's judgment is based on experience, on an understanding of raw materials available, and knowledge of basic cooking principles and food science. So to truly master any recipe, it'll take insight and practice. Looking at heat and food. To cook food means to heat it, to make certain changes in it. Skillful cooks know exactly what changes they want to make and what they must do to get them right. To learn these cooking skills, you need to know why foods behave as they do when heated. For this, you have to study the theory. Starting with the basics. So what is heat? Heat is a form of energy associated with the motion of atoms or molecules. When a substance absorbs heat, its molecules move faster. In liquids and gases, the molecules move more quickly from place to place and bounce off each other more frequently. The molecules stay mostly in place in solids, but vibrate with more energy. Temperature can be defined as a measure of this molecular activity. The higher the temperature, the faster the molecules are moving. Looking at the effects of heat on foods. Foods comprise proteins, fats, carbohydrates, water, and some small amounts of other compounds such as minerals, including salt, vitamins, pigments, such as coloring agents, and flavor elements. Understanding how these components react when heated or mixed with other foods is important. You will be better equipped to correct cooking faults and anticipate the effects of changing cooking methods, cooking temperatures, or ingredient proportions. When you know why foods behave as they do, you can understand how to get them to behave as you want them to. The following parts of this video is concerned with the physical and chemical reactions that affect the components of food. Starting with carbohydrates, or carbs. Number 1. Starches and sugars are carbs. Both components are present in foods in many forms. They are found in fruits, vegetables, grains, beans, and nuts. Meat and fish also contain a small amount of carbs. Number 2. For the cook, the two most important changes in carbs caused by heat are caramelization and gelatinization. Caramelization is the browning of sugars. The browning of sautéed vegetables and the golden color of bread crust are forms of caramelization. Gelatinization occurs when starches absorb water and swell. This is a major principle in thickening sauces and the production of breads and pastries. Acids inhibit gelatinization. A sauce thickened with flour or starch will be thinner if it contains acid. Next, fruit and vegetable fiber. Number 1. Fiber is the name of a group of complex substances that give structure and firmness to plants. Fiber cannot be digested. Number 2. The softening of fruits and vegetables in cooking is in part breaking down of fiber. 3. Sugar makes fiber firmer. Fruit cooked with sugar keeps its shape better than fruit cooked without sugar. 4. Baking soda makes fiber softer. Vegetables should not be cooked with baking soda because they become mushy and lose vitamins. Going into proteins. Number 1. Protein is a significant component of meats, poultry, fish, eggs, milk, and milk products. It is present in smaller amounts in nuts, beans, and grains. Number 2. Proteins consist of long chains of components called amino acids. These chains normally form tight coils as proteins are heated. The coils gradually unwind. At this point, the protein is said to be denatured. The critical fact about denaturing for the cook is that when protein coils unwind, they become attracted to each other and form bonds. This bonding is called coagulation. The coagulated proteins form a solid network of bonds and become firm. As the temperature increases, the proteins shrink and become firmer and lose more moisture. Exposure of proteins to excessive heat toughens them and makes them dry. Most proteins complete coagulation or are cooked at 160 degrees to 185 degrees Fahrenheit. 3. Many protein foods, such as meats, contain small quantities of carbs. When proteins are heated to about 310 degrees Fahrenheit, the amino acids in the protein chains react with the carb molecules and undergo a complex chemical reaction. The result is that they may turn brown and develop more decadent flavors. This reaction is called the Maillard reaction. It is what happens when meat browns. Because of the high temperature it requires, the Maillard reaction takes place only on the dry surface of the food. Because of its water content, the meat's interior cannot get this hot. 4. Connective tissues are particular proteins present in meats. Meats with a great deal of connective tissue are tough, but some connective tissues are dissolved when simmered with moisture. Cooking tough meats properly therefore makes them more tender. 5. Acids like lemon juice, vinegar, and tomato products have two effects on proteins. The first one being is that they speed coagulation. The second one is that they help devolve some connective tissues. Lastly, let's take a look at fats. Number 1. Fats are present in meats, poultry, fish, eggs, milk products, nuts, whole grains, vegetables, and fruits to a lesser extent. Fats are also important as cooking mediums for frying. 2. Fats can either be solid or liquid at room temperature. Liquid fats are called oils. When solid fats are heated, they melt or change from solid to liquid. The melting point of solid fats varies. 3. When fats are heated, they begin to break down. When hot enough, they deteriorate rapidly and begin to smoke. The temperature at which this happens is called the smoke point, and it varies by type of fat. A stable fat with a high smoke point is important in deep fat frying. Number 4. Many flavor components dissolve in fat, so fats are important carriers of flavor. When fats melt and are lost from food, some flavors as well as some vitamins are lost with them. Understanding how these forms of food interact with heat will make you a better chef. Many aspects of cooking is directly related to seeing these physical changes and understanding what is happening on a molecular level. Practice some of these examples listed in this video at home, such as toasting bread, making jam, or sauteing ingredients, and study how the structure and flavor changes. I hope that you found this video to be helpful, and thank you for watching the Culinary Study Guide. Catch you next time. Bye.